This question is number 9 from May 2014, paper 2, time zone 2, and it is a question that gets into some elements of both kinematics with differentiation and kinematics with integration. So let's get into it. First thing, let's take a look at what we have. We are given a velocity function. V of t is t squared minus 4 quantity cubed. We're given a time interval over which it applies. And we're asked some questions about it. First thing is to find the velocity of the particle when t is equal to 1. They're looking for you to just realize that you are just being asked here to evaluate v of 1. This is a velocity function, so you just have to figure out what is the velocity when t is equal to 1, and you get that by evaluating substituting t equals 1 into that expression. So v of 1 is going to be just 1 squared minus 4 cubed. This is a paper 2 question, so you probably can do this without a calculator, but it's always worth checking because you have the calculator there to help you. So substituting in there, 1 squared minus 4 is -3, -3 cubed, you end up with -27 as your answer there. Next thing is the value of t for which the particle is at rest. Particle at rest, that is a clue telling you that v of t, that function for velocity, is 0. That's what rest means. So you are looking for a place where t squared minus 4 raised to the 3rd power is equal to 0. This is a paper 2 question, but it also does say find the value of t. So this right here, writing out this equation, t squared minus 4 cubed is equal to 0, is essential. Like you really want to show what it is you're doing. Coming up with some sort of working, demonstrating what it is you're doing, like just saying this is going to be 0 if t squared minus 4 is equal to 0. Generating that t is equal to plus or minus 2 would be good. Also, because this is paper 2, you could just use the graph and make a sketch of what this actually looks like. Wow, that's really bad. Sorry. Isn't that helpful to just see my drawing about axes? Okay, it's fine. T is equal to plus or minus 2. The important thing that you absolutely must do is go back and notice that the interval is 0 to 3, so your final answer there must be that t is equal to positive 2. You don't get that final 3rd answer point unless you do that, so make sure you do it. It then asks us for the total distance the particle travels. This is the piece that is new. Remember that distance is the integral, and it says the first 3 seconds, so let's go t equals 0 to t equals 3. The way you find distance from a velocity versus time graph is by taking the absolute value of the velocity function and integrating it with respect to time. That is our definition. And so part of getting credit for this is stating that, like having an integral expression that correctly states that. You can write it with the integral expression already in there if you want. You can write this as the absolute value of our expression t squared minus 4 quantity cubed dt, like you can put that in there. Either way, just showing that you know that this is the definition is that first answer point. But notice that this is a 3-point question. There's not a lot that you're expected to do. This is paper 2. This is an integral, so what you need to be able to do is evaluate this on the calculator. There are a couple other ways you can do this. You could look at the graph and see that you can actually break this up into 2 integrals based on when this function is positive and when it is negative. So it is negative during this portion of that interval from 0 to 3. So from 0 to 2, we're going to take negative t squared minus 4 cubed dt. And then we could add on the displacement between 2 and 3 of just the function when it is positive, t squared minus 4 cubed dt. Okay, so you could do this, but don't evaluate this manually. You don't get any credit, really, for evaluating this. You just get credit for that final answer. So use the calculator to do this for you. You get a value that is approximately equal to, so all of this is approximately equal to 86.2571. I think it goes on a couple more places. But remember, last step, you need to round that answer to 3 sig figs and get that as 86.3. And let's check our units. So it does say that velocity is in meters per second, so this is actually 86.3 meters. You don't lose any credit for not having the units there. And the way you know that is that it doesn't actually state the units. Just something to be aware of. So part D asks about show that the acceleration of the particle is given by this expression. To do that, you need to remember that the acceleration function is the derivative, first derivative of the velocity function. So we need to find v prime of t. Take the derivative with respect to time of our expression, t squared minus 4 quantity cubed. This is something crying out to us to use chain rule for. So this is our inside function right here. And so something cubed, if we're taking the derivative of it, that is going to be 3 times that something squared. So 3 times t squared minus 4 to the second power. But this is a composite function, so we now need to multiply by the derivative of the inside, which is 2t. And we can just rearrange this to make it so that our answer looks like what the question states. Because it does say show that the acceleration is this expression, so you need to have as your final step that very expression. Last part, part E, asks you to find all possible values for which velocity and acceleration are both positive and both negative. There are a lot of possible ways to do this. You could show potentially that over the interval, because remember we are looking at this interval 0 is less than or equal to t, which is less than or equal to 3, show, like one thing you could do is show using the graph, looking at the graphs to decide where the graphs have the same sign. In order to get that method point, you would need to sketch both of them. So these would just be sketches. The intercepts would have to be about right. So you would want to make sure that you sketch those correctly. From the window of your calculator, you would make sure that you have some scaling on your axes. You're going 1, 2, and 3, and just sketch the two graphs. So I can go ahead and do that. I don't have it on my screen, but I will sort of pretend that I'm doing this in front of you, and maybe you should on your own graph both of these functions just to check. If you're using your graphing calculator and your calculator is using the variable x, just make sure that you convert all the t's into x's. So we have our f of x, our velocity function of x squared minus 4, all raised to the third power. And so that graph sort of at t equals 2 looks like sort of this a little bit. So this is velocity of time. And then our acceleration graph And it might be a little tricky to get the window just right on this, just sort of looking at it, but we have sort of a, well, I guess it goes up. Oopsies, so it goes up. It bounces at 2 and then goes up like that, so that's a of t. And so from those two graphs, what you can obtain is that the interval where this actually occurs, velocity and acceleration are both positive, occurs over the interval 2 to 3. So 2 less than or equal to t, which is less than or equal to 3. And actually, I'm seeing now that actually at 2, we do not want to include t equals 2, because at t equals 2, both velocity and acceleration are 0. I think that's going to do it. You could also do this by showing that acceleration versus time. If you had a sign diagram for acceleration versus time, you could show that at t equals 2, acceleration is 0, that it is positive on this side and positive on that side. And since we're only going from 0 to 3, you could say that acceleration is always positive. Okay, so the only thing you would need to do is figure out when is v of t also positive. And so you can see that v of t is going to be 0 here, it is positive over here, and negative over there. That gives you this exact same answer that we obtained using the graph. So whether you use some sign diagrams like this or the graphs as you see right here, either method is fine. You just have to show what method it is you